Now, inshallah, what we'll be doing now is we'll do a activity to begin with on the bridge design pattern we covered on Thursday. And then after that, we'll have a look at the third category of design patterns today, which is the behavioral design patterns, right? So let me go and upload this activity. Are you guys able to access the activity in the file folders, class activities?
Yes, we have
Okay,
class.
okay, that's good. So let me also share the activity here. Are you able to see the screen?
Yes.
Okay, good. Now, I'd like everyone to try this individually as well, right? But before that, let's look at the problem itself and let's do it step by step. So what we are talking about here, we're trying to see another example of bridge design pattern. And remember, the bridge design pattern is all about decoupling an abstraction from its implementation so that the two can vary independently, right? And we're gonna look at the thread scheduling example. And what's happening here is that we have a thread scheduler, and there are two types of thread schedulers. One is your primitive thread scheduler, and one is your time slice thread scheduler. So basically, two different kind of algorithms we have. And it has its own implementation when it comes to Unix and Windows, and so is true for time slice thread scheduler. It can have a Unix implementation and Windows implementation. So moving forward, what we are saying here is that there are two types of schedulers and there are two types of operating systems or platforms. Now, if I say that I want to add a new kind of a platform, say for example a Java virtual machine, what would our hierarchy look like? So if you want to stick to the same hierarchy, for example, to begin with, and I have to add a new Java virtual machine, how it will look like. So kindly take a few minutes, a couple of minutes, 2-3 minutes, to see if you can come up with an updated version of the same schedule hierarchy by adding Java virtual machine. I'd love to few of you guys to try it online so that you can share your solutions or share the screen with us so that we can discuss. Go ahead, please. Everybody got the question first before everybody's clear what we need to do and what kind of system we're talking about here?
Doctor,
Yes, please.
should we deal with the Java virtual machine as an operating system or as a new kind of threading?
A new operating system or a new platform.
Okay, thank you.
Right, so it's a new platform, and we want to now support this platform in our system, for example, right? As I said, I love a few of you guys to try. I mean, I want all of you to try, to be honest. But if you can do it online or you use one of the machine or or online drawing tools, so that we can share the solution here with us in the chat, or even share your screen so that we can have a discussion on this. Go ahead, please. Okay, anybody would like to volunteer to share his screen or share his drawing? This is pretty much, I believe this is the easiest part. The
Could
chat.
could you please give us like more
Oh,
time, like
sure,
2 minutes?
Yeah. Take your time, please. Yeah, we'll wait for maybe a couple of more minutes, please. That's okay. Okay, we got one. Saud got one here. Thank you, Saud. Yeah, that's spot on. So if we really have to, do it something like this, where it is, yeah. So probably something like this will do it, right? Sorry, not this one. Where it is. Design pattern. Something like this, right? Everybody is on board with me on this one?
Yes, teacher.
Okay, so see what's happening here. We have the Java virtual machine here. We just add that one, and then we have this Java virtual machine for this time sliced one, right? Now, let's look at the second one, which is more important and more interesting. So what we're doing here now. In this case, we just added these two, new platforms into the preemptive threshold and the time slice threshold. Uh, we have new problem here that, okay, this was easy. We just added them here. Now, what if we have 3 kind of time schedulers and 4 different kind of platforms? What if we have five kind of schedulers and 10 different kinds of platforms, right? What will happen? This will really become a challenge, isn't it?
Yes.
That if you're going to have 10 different kind of platforms or 5 different kinds of algorithms and maintaining them and updating them. So here the bridge design pattern really comes into handy, and the whole idea is that you try to refactor, kind of decouple the abstraction between its implementation and so that the two can vary. So can you guys try this one now with this original problem? See if you can apply the bridge design pattern now.
Yes, sure.
Go ahead, please. Try to decouple. Okay, so we got solution here. Muhammad got one. Basically, yes, that's spot on. You basically go on and change the abstraction. So you change the threads and implementation of the virtual machines. Absolutely correct. Everybody else got the same or similar one? Something like this, right? Everybody on board with me here now? This is
Dr. What?
sorry, this is the same one, right? We just created,
Yes,
correct?
yes, this is the same one.
Yes, same one. So the other one will be what? It's actually my copy paste is not working correctly. Let me again copy it. Let me again copy it and do it this way. Here we go. See? So basically you decouple the schedulers, the algorithms from its implementations. And the moment you have done this, you can go on and keep changing the operating systems of the platforms, or you can keep changing the algorithms here.
Doctor, I have a question.
Yes, go ahead,
Sorry.
please.
Does the thread scheduler implementation use the thread scheduler, or does the thread scheduler use the implementation?
The thread, so it's the thread scheduler uses the implementation.
Oh, not the. Okay. Thank you.
Yeah, it's a one directional or unidirectional. So everybody's comfortable with this. Is the bridge design pattern more clear today?
Yes, it's clear.
Right. Yeah, and you will see that bridge design pattern, is really helpful in a lot of situations, especially in those situations where you're going to have, different kind of operating systems. You want to support your application for so many different kind of operating systems, and at the end of the day, you want to make them flexible so that the abstraction is different from your implementations.
Doctor, I
No,
have a question.
yeah, go ahead, please.
Sorry.
That's okay. Go ahead.
Can you go down, please, to the graph? Yes. Yes, this one. How the thread scheduler implementation don't use the thread scheduler, and why? Because I believe that the implementation should use the thread scheduler, not the way around.
The implementation should use the thread
Thread
scheduler.
Yes.
Yeah, no, see, which one is the interface here now? That's the question. Which one is the interface here?
Isn't
Because
it?
at the end of the day, you will be decomposing the components interfaces, right?
Yes, of course.
Yeah. So the interface class will contain a pointer to the abstract implementation class.
Okay.
Right. So basically, what will happen here is that what will be the interface here now, and which one will be the abstract implementation class?
Isn't the thread scheduler is the interface?
The thread scheduler. Yes,
Yes.
it's an interface. Yes.
Yes.
And
And
your thread scheduler implementation is your abstract class, right?
yes.
Right. So what will happen? It will go on and create, concrete implementation classes, right?
Yes, of course.
But all of these will interact with this thread scheduler interface to separate the implementation from the abstraction. Naturally, you will still have to have, you will still have to go on and implement them, correct?
Yes, yes, of course.
Of course, right? But the difference now here is from the previous solution here is that, now if you add one more platform, it will be only on this side.
Yes.
Or if you add one more algorithm, it abstraction will be done on this side.
Yes.
So these two are now decoupled.
Okay, I get it now. Thank you, Doctor.
So this is the whole idea. They are basically, it's allowing you to, of course, at the end of it, it's a structural design pattern. So it's allowing you to better structure rather than having this structure, right? Where, basically it's very tightly coupled, and every time we're going to have a new platform, you have to go on and change in all of different places. It's kind of, helps you decouple the structure of the system.
Victor,
Yes, please.
what about the second algorithm? Where will be implemented?
The second algorithm, this one.
Yes.
Ah,
Because in the
okay.
implementation here, you only show the first algorithm, the primitive.
Okay. Now, of course, the second one will be here as well, right? It's just a snapshot.
Okay. So as a concrete classes or as another interface?
As a concrete classes.
Okay. So we'll have 6 concrete classes.
Yes,
Okay.
because yes, true. Because we cannot, we cannot avoid that. But the difference is that, structurally they are two different structures now. Right. So if you
Yes,
make a
I got
change
it.
here, if you make a change here, it's not really gonna make a change on this side as such, right? Or they are, independent now. Everybody's comfortable with this now? Now I have a last question for you guys. How bridge is different from abstraction? Sorry, from adapter design pattern. Remember the adapter design pattern? The VLC player, the MP4 file player.
Yes.
Right. So how that is different from a bridge conceptually?
Yes, I believe that the adapter is like connecting two components, and one of them is not specific for your application, but the bridge, it's all of it are specific for your application, and you do it by yourself, not taking
Absolutely.
it from
Yeah,
another
absolutely
source.
true. Yeah, absolutely true, South. You're spot on. This is the whole idea. Adapter is where you're trying to connect or glue independent applications, and sometimes these packages could be incompatible as well. While in the bridge, you are designing from your application from beginning in such a structural way that they are decoupled and you can go on and manipulate each side accordingly. Okay, so that's the idea. Everybody's clear with the difference between adapter and the bridge? Because I believe sometimes we get confused about this. Okay, so I think everybody seems to be happy with this. So now with this, let's move on to the last category of design patterns. Are you able to see the screen here?
Yes.
Okay. So let's move on to the third category of design patterns, which are the behavioral design patterns. Now, as we said, like in the beginning, there are three main categories of design patterns. One is your creational design patterns, which allows you to create objects, either in a constrained way or in a more organized way, like singleton and factory and abstract factory and so on and so forth. Similarly, we went through a range of structural design patterns like the or the adapter or the facade, which allows you to organize your structure in a more organized way, in a sense, so you can get better design properties out of it. The third one is your behavioral design patterns. Now, again, in behavioral design patterns, there are a whole suite of different design patterns available in the catalog. Of course, will not be going through all of them, because we have to move on to the other topics in the course now, because we're almost getting towards the end of the semester. So we'll be just going through three of them, the ones which I believe are quite popular out there in the market. And, we'll be looking at these three ones: the iterator, the mediator, and the observer. Any one of you guys have used any one of these design patterns? Ever experienced any one of these design patterns?
We might use it, but without any knowledge, like
Yeah,
use
it's
it
just,
by chance.
yeah, it's quite possible. It's quite possible. So let's look at these ones. Probably we'll try to see if we can cover these two ones. Observer, inshallah, we'll leave it for Tuesday. So let's look at iterator. Now, iterator pattern is something which is very commonly used design pattern in Java and .NET programming environments and other OO programming environments. The whole idea behind iterator design pattern is that you get a way to access the elements of a container or a collection in a sequential manner without any need to know its underlying representation. All right, so you want to iterate, as the name suggests. So you want to iterate through a data structure, and you want to access the elements of it, which is basically a collection of an object in a sequential manner without any need to know its underlying representation. So let's look at this example, what's happening here. Take a moment to look at the structure of this class diagram and see what what comes to your mind. Okay, so what's happening here? We have two interfaces called container and iterator, right? And this container allows us to, get iterator, and similarly, the interface iterator allows us to manipulate or go and traverse the container with has next and next methods. So and of course we have the name repository is one of the containers from which we want to traverse, and then iterator specifically for this name repository to go and traverse it. So let's look at the source code and then we'll come back to this slide to discuss. So we have two interfaces, iterator and container. Something called iterator, which will allow us to go has next or next right. And then the interface container, it will get back to us an iterator. We create a concrete class which will be implementing something called name repository, which will be implementing the container interface, and then we will have something called inner class called name iterator, which will be implementing the iterator interface. So take a moment to look at the source code and see what's happening there. And then we'll discuss the source code. Okay. So what's happening here, guys? Anybody will volunteer to talk about it?
I think what happened that is it's like a sequence, make things in sequence, and you can't go back. You just can go forward, and whenever you reach the end, you can't go further. You can't go back and start again.
So basically what's happening here is that we have something called an array names, right? So that's why we're calling it a name repository in a sense, right? So we have an array of names elements. And then what's happening here? Because we are implementing the container, right? And remember the container had this get iterator method interface, had this get iterator signature. So basically we are implementing get iterator, and in this case we will be returning a name iterator now. Now what's a name iterator? Name iterator is in an inner class. You know, what's an inner class, guys?
A class used only inside a class, inside another class.
Inside another class, right? And it's only accessible from only that class, correct?
Yes, of course.
So basically we'll have a private class called name iterator, and then we'll be creating an index here. And then since it will be implementing the iterator interface, it has two methods in this case. Has next, which basically goes and sees whether you have an element in do you have a next element in your array or not. And then you have a method called next, which basically does what? It checks whether you have a next element or not. If you have a next element, it will just go on and return the next element to you, correct? Now, everybody is comfortable with this piece of code?
Yes.
Okay. Now, when we go to the demo class, what's happening here? So we're basically going on and creating a name repository, right? And then we are basically traversing through this name repository by first of all getting its iterator, which will help us traverse. And what will happen here when you say get iterator? It will come here and will, as a result, we'll get a name iterator. And because name iterator allows you to next, basically you will go on and check whether you have a next element. So you keep doing this. If you have a next element, basically, you know, you will just iterate to the next one and print the name out. Now the question is, what's the benefit here?
Doctor, I think that just a moment, there is a problem.
Yeah, there was a bit of echo, Muhammad.
Maybe to make things in order or in sequence.
Of course, it's a way to access the elements of an object in a sequential manner without any need to knowing its underlying representation. What's the benefit here?
Doctor, I think that we don't have to know what's the structure of information inside the class.
True, true. Anything else? Basically, if you notice, the iterator pattern is doing what? It decouples algorithms from the containers, right? So basically, as a demo class, what you were doing, you said, I want to traverse named repository, right? Now, there is no relationship like this here, where you can go and, you know, traverse through the name repository directly yourself, or you can, you know, the way you like it. No. What is happening here is that it's allowing you to traverse the name repository by the specific algorithm or the way you want the container to be traversed. In this case, you know, has next and next. So you have basically decoupled the container, right? You have basically decoupled the container from the algorithm. This means what? Can I change the algorithm and the demo class will be impacted?
I didn't think so. It will impact it if you change the algorithm.
Yeah, so for example, if I come here and rather than going, to the next element, if I say index plus 2, will it have an impact on the demo class?
It will impact only the output.
It will, because you have changed the algorithm, right?
Yes.
But as a result of this design pattern, what you are really doing, of course, this is your design pattern, right? You're creating an iterator and you're basically separating it from the container. So you're kind of decoupling the algorithms from the container. And as a result, if you change the algorithm, the container doesn't need, is not impacted in a sense that them or the classes who are using or trying to go through that container. And that's the strength of this design pattern. Is this design pattern clear to everyone? Probably slow today because of Sunday, I think so, isn't it?
I think it's clear.
It's okay. Okay, I'll take it this way. Okay, thank you. Thank you.
You're welcome.
Okay, now let's move to the next one, which is the mediator one, right? Now, this is also very, very easy. And what happens in a mediator design pattern is that you use mediator design pattern to reduce the communication complexity between multiple objects or classes. And what really do is basically create a mediator class, and this mediator class is actually responsible for handling all the communications between different classes. And of course, as a result, what you do is you basically becomes easy for you to maintain the piece of code, make it decoupled or loosely coupled, right? They don't really depend on each other that much. So in a nutshell, the mediator design pattern is there to reduce the communication. Remember, it's a type of a behavioral one, right? So it's the whole idea is to, somehow impact the behavior or the communication. And the aim of mediator is to reduce the communication between multiple objects. Of course, you need to create a mediator class, which will be now responsible or normally handle all the communication between classes. A very typical example of mediator design pattern is the chat room, like the chat room we have now in our teams, for example, and many other places. So basically what happens is that in a chat room where multiple users can send messages to the chat room, and it is the responsibility of the chat room to show the messages to all users. So basically, we create a mediator called chat room, and chat room acts more like a mediator, and it will be receiving all different communications, and it will be making sure that all the users are able to see this message. Let's look at this example. So we have a demo class which will be using it. We have different users with their names and setters and methods, and the users can send messages, while the chat room will be responsible for showing the message. Right. So basically, we create two classes called chat room and user, and the user object will use the chat room method to share their messages. So basically, what's happening here? We have a chat room, which is our mediator class, right? And this chat room or class is only responsible for showing messages in this case. So he will say, what are the user and what's the message, and it will display it for you. While the users, of course, can they have their own setters and getters, and of course its own constructor, and it will be only responsible for sending message. So it will say, okay, send this message, and the way it will send this message is basically send it via the chat room. Right, so basically, you'll say send a message. A chat room dot show message will be called, and it will display the message. So let's look at from a demo side. Basically, what will happen? You have two users, Robert and John, right? and Robert will send a message, hi John, and John will send a message, hello Robert. It will be displayed to each other, because when the Robert will send a message, what will happen? Send message will go on and call the chatroom.show message, and then chatroom.show message will basically go on and display it for you. Okay. So basically, it's one of those very simple ones. What's the benefit here now? Is the design pattern clear? It's one of the probably the easiest ones.
It's clear, but
Yes.
what's the benefits? Here the
yes. Yeah. What's the benefit here? The benefit here is, anybody would like to comment?
Can we say that single responsibility?
It will be single responsibility in a sense. Yes, absolutely, because chat room will be responsible for what it's supposed to be doing, right?
Yes.
Again, the main benefit here is it will do what? It will handle all the communications between different classes, and as a result, use the complexity of the communication between multiple classes. So basically, rather than users sending message to each other, like you have 100 users in your system at the moment, like for example, in our class at the moment, in our Teams class, we have 37 students, attending this session now. If I have to send a message in the chat room, for example, the way I'm doing now, a test message, it's a chat room class which is handling this. Is a mediator class which is responsible for displaying to the all users, right? Rather than each class making a connection or a communication with each individual other user. Okay, so that's the biggest strength of the mediator design pattern. So as long as you have such a situation where different classes need to communicate with each other, probably the best solution is the mediator design pattern. Do you see any link with your publisher subscriber design architectural style as well? Remember the publisher subscriber architectural style?
Yes.
Yes, Doctor.
Yes,
But
remember?
the difference here, I think that any user can be a publisher.
Yes. So it's not one-to-one mapping, but just as a concept.
Yes.
Yes, it's not one-to-one mapping, but just as a concept. Right, so basically this is it for today. I think we'll be, just to be synchronized with the other section, inshallah, we'll look at the observer design pattern, which is the last of the design patterns I aim to cover in this course. Inshallah, we'll look at this on Tuesday. And then inshallah, we will be, moving on to, inshallah on Tuesday also I'll give you a lecture on good design principles. I'll summarize all of these things we have learned. Then we'll move into code bad smells, refactoring, and then we'll move into the last official topic of the course, inshallah, which is the software construction. So we're nearly getting there, inshallah. You already see that there are a lot of code coming in at this stage of the course. Inshallah, in the next, we're already in the week 12, so probably in the next, 6 to 8 lectures, we'll be focusing on how almost at the code level, how at that specification level we need to make sure that how we specify the preconditions and post conditions and all of that stuff, inshallah. Okay, so let me stop the recording. It's almost 10:50, so let me stop the recording, inshallah, and take the attendance. And of course, the floor is open for any questions. Otherwise, inshallah, I'll see you on Tuesday.